Hello, in this video, I'm going to review unit circle. But before we review unit circle, we need to review trig functions first. So let's look at sine, cosine, tangent functions first. So sine function, y equals sine theta, relates to quantity. What are those two quantity? Angle measure theta to vertical height of the point above the horizontal diameter measured in radius length. Measured in radius length just means we divide by the radius length. So let's say we have this angle right here, theta. Okay. Then essentially then we have a circle like this. So if you want to find sine of this angle right here, sine of theta, what we're measuring is this vertical distance from horizontal diameter. So here's horizontal diameter, and we measure this vertical distance from horizontal diameter to this point, the end of the terminal ray. Okay, and divide by the radius length. This is radius. Let me do it differently. Divide by radius. Okay, so if we label this height as y, if this radius is r, our sine theta is y divided by r. Okay. Let's do another one. What if I want to measure, let's say, this angle right here? This highlight angle. This is the angle. Oops. This is the angle, theta. Then here is a terminal ray, right? So if I want to measure sine of this angle, sine of this theta will be, again, this, here's the horizontal diameter of the circle. It will measure vertical distance to the terminal ray. And this distance divided by radius length. So let's call this maybe t. This height is t. Then t divided by radius length. Okay. But if you look at this circle right here, this right here, the reason why we mark just sine theta, this blue segment right here, is because in here radius length is 1, because this is a unit circle. So we're essentially dividing this length divided by 1, which is just the length itself, because divided by 1 does not change the quantity. So that's the definition of sine function. It is very important for us to understand the sine as the vertical distance from horizontal diameter to the terminal ray of the angle. Okay, measured in radius length. But when we're talking about unit circle, radius is 1, so we just divide by 1. So it is just the vertical height on a unit circle. So let's review sine. Okay. Similarly, we can think as we have a circle for any angle. And let's say I want to find sine of this angle right here, for example. This is the theta angle. Okay. So then cosine of this angle measures horizontal distance from vertical diameter. So now we have a vertical diameter. Here's a vertical diameter. And we measure horizontal distance from this end of the terminal ray to vertical diameter. So this, we measure this distance right here, this red segment. So let's call this segment x. X measured in radius length. That means we divide by radius length, r, divided by r. So cosine is measuring horizontal distance from vertical diameter, measured in radius length. Similarly, on unit circle right here, on unit circle, radius is 1, so that's why we only just get the horizontal distance. Okay, so let's do one more just to get conceptual idea. What happen? I want to measure, let's say, this angle right here for cosine. So then the way we think about it is, okay, let's look at, here's the vertical diameter, and I want to measure this distance right here from vertical diameter to the angle, terminal ray, measured in radius length. So let's call maybe this length S. So then cosine of this orange, this angle, equals S over radius length. So this is what sine and cosine measures. Okay. Again, try to train yourself, as we talked about in module 2. Try to train your thoughts so that we think about in terms of horizontal and vertical distance from either horizontal diameter or vertical diameter. So then what does tangent function measure? Tangent function measures angle theta and the slope that angle theta produces, the slope of the terminal ray. Okay, so slope is change in output over change in input. So let me draw, let's say I have this angle right here. Tangent measures slope of this line. In order to find that, we do changing in output, change in y over change in x, which is why we can also do sine theta over cosine theta. But the meaning of tangent function is angle as input and output slope. So basically, if you look at this graph right here, b over a, so vertical distance from horizontal diameter, divided by horizontal distance from vertical diameter. So vertical distance divided by horizontal diameter, vertical distance divided by horizontal distance gives us slope. So that's a tangent. But we can also express this because vertical distance is sine theta, and because horizontal distance is cosine theta, we can write it like this, sine over cosine. So this, the definition is actually the slope, but we can also express in sine theta over cosine theta. So keep that in mind. So on unit circle, it means that we have a center at 0, 0, radius of 1. Okay. Which is why we can just express, as we saw earlier, the vertical distance is sine theta, sine of angle t divided by 1. But dividing by 1 does not change the quantity. That's what we just write as sine of t. Whereas for cosine, horizontal distance, so we do have to do this distance divided by 1 because we have to divide by radius. But because radius is 1, we can just express as cosine t. Okay. And in x and y coordinate, x value is cosine and y value is sine. Okay. So using this idea, we organize some of the angles, some special angles. So what are these special angles? We have pi over 3, pi over 6, pi over 2. And pi over 4, pi over 4, pi over 2. Okay. These are also known as 3, 30, 45, 60, right? So this is known as 30, 60, 90 triangle, where this is known as 45, 45, 90 triangle. And these two triangles have same ratio between its distance. So if radius is 2s, okay, if radius is 2s, this horizontal distance from vertical diameter is always half of radius. And this length right here, which is vertical distance from horizontal diameter, is always square root 3 times s. For 45, 45, 90 degree, or pi over 4, pi over 4, pi over 2 triangle, we have radius as square root of 2 times s, and each distance, horizontal and vertical distance, both are just s. Okay. So using these two relation between this distance, we can construct unit circle. So what are some tips of memorizing unit circle if you want to memorize? First, we have to, again, understand the definition of sine and cosine in terms of distance from vertical or horizontal diameter. So then, here's some tips. Let's talk about how we can first, we have to remember there's pi over 4, right? Again, if you don't understand, let me write pi over 4. Pi over 4, right? Pi over 4 is in radian. Again, we need to understand angle measured in radian without relying on degree, as we talked about in module 2. Okay, so there's pi over 4, and here is pi over 6, and here is, let me write it better, pi over 3. Okay, so then we want to find sine and cosine values. Okay, so here, if you look at, let's say, like this unit circle, radius is 1. So let's look at this point first. And here, what happens is the height, this height represents sine. So this height is half, as we written here, okay, and square 3 over 2. And here is square 2 over 2, square 2 over 2. This is same, so this distance and this distance is same. Okay. Now for pi over 3, it actually switches. So this switches from pi over 6. So this distance right here, let me highlight it, this distance right here is same as this distance. That's why sine and cosine value switches. Right here we have half and square 3 over 2. Let me write that better. So, which is also why this distance right here is same as this distance. Okay. So then let's look at this right here, these two values right here on the edge. So here, look at this. We don't have any vertical distance, which is why cosine value is 0. Oops, sorry. I meant sine, which is why sine is 0. Because we do not have any height, right? But we do have horizontal distance of 1, radius. Here, it's opposite of that, right? Height is 1, which is why sine is 1. For cosine, there's no horizontal distance, which is 0. Okay. So this is how the first quadrant works. Once you understand the fourth quadrant, second, third, fourth quadrant follows a pattern. So let's talk about the pattern right here. Okay, so here's a x and y coordinate. Let me draw a circle. So let's pay attention to the patterns. So first, we must remember this angle right here, pi over 4. Pi over 4. And this angle right here, pi over 6. Oh, let me draw maybe better scale. Pi over 6. And here is pi over 3. Okay. And here is 0. And here is pi over 2. So this point right here is 0. Oops. 1 comma 0. Right? So let me write this. Here's x comma y. This is, oops. cosine theta, comma sine theta. Again, theta is the angle measure. So then here we know at pi over 4, we have same value, square root 2, comma square root 2 over 2. At pi over 6, again, there's essentially 3 numerical values we'll be using. Square root 3 over 2, half, and square root 2 over 2. Square root 2 over 2 is only used at pi over 4, and other angles are similar to pi over 4, and we'll talk about that in a second. And here, so let's look at this. This distance is sine, is half. And now this distance right here is square root 3 over 2. Square root 3 over 2. Okay. And when we think about this, square root 3 over 2 is bigger than half. And we can also think that this distance is bigger than this distance right here, right? That's why we write square root 3 over 2 first and half. At this point, let's switch though. Okay. So here's the green distance. Here's the orange distance. Okay. So we have half, comma, square root 3 over 2. And at pi over 2, we get 0, comma 1. Okay. So once we know the first quadrant, second, third, fourth quadrant follows the pattern. Okay. So let's see how the pattern works. Okay. So first, let's get the somewhat of simpler points out of the way. So here, 1, 0. So this right here, just think in terms of x and y coordinate, right? We have negative 1, 0. Here, we have, again, x is 0, y will be negative 1. Okay. So then, let's mark the angles here. So we have this angle right here, and another angle right here, and another angle right here. Oops. Okay. So this right here will be 2 pi over 3. Okay, and you can think as it's similar to this one right here, pi over 3. Okay, and multiply 2, we get this. Okay, so when these two angles are actually so like 2 pi over 3 is twice as big than pi over 3, and that's actually what's happening here. In terms of this point right here, this point, we can use this point right here. In terms of numerical value, same, but now sine, we know that second quadrant, x value is negative, so we have negative half, comma, square root 3 over 2. Now let's look at this. And here we have 3 pi over 4. We will multiply 3 to pi over 4. In terms of value, again, we follow this pattern. Negative square root 2 over 2, comma, negative square root 2 over 2. Like this. Okay. So now again, similarly here, this angle right here will be from pi over 6. Now we have to multiply 5. Okay, so 5 pi over 6. 5 pi over 6. So then we have negative square root 3 over 2, comma, half. Okay. So what does that mean? Again, it's important to know the meaning of these. For example, this means that this distance right here is negative square, well, this is positive square root over 2, right? And this distance will be negative square root over 2. So here, so it looks like a half, but actually I just meant to write. Well, let me erase and do it again. This is just negative square root over 2. So in second quadrant, we have negative values, negative x. We have negative x from first quadrant. Okay. And third quadrant, as you can see, both we have negative x, negative y from first quadrant. And fourth quadrant, only y values are negative. Okay, so that's a generic pattern. So once you know the first quadrant, we can draw all the quadrants, right? So then let's look at this one. So let me draw this angle first here. Then we draw this one. And draw this one. Okay. So how can I remember this angle? This angle is essentially adding pi from this pi over 6. Adding pi. So pi over 6 plus pi gives me 7 pi over 6. 7 pi over 6. Okay. And same for this one. This right here, as you can see, pi over 4. We add pi, then we'll get 5 pi over 4. The next one, we add pi from pi over 3. So it's kind of connected like this. Oops. Well, let me use different color. So from pi over 3, this angle right here, we add pi to come to here, right? Which gives me 4 pi over 3. So that's a way we can think about to remember these angles. Okay. So then, all these points come from first quadrant, but all negative. So this one will be negative square root 3 over 2, negative half, negative square root 2 over 2, negative square root 2 over 2. Here we have negative half, negative square root 3 over 2. Okay. You can also think as, okay, this value matches with this one right here, except that both signs are negative here. This value right here matches with this value right here, except that both are negative. And same for here. Okay. So let's look at fourth quadrant. Fourth quadrant, now we add pi from, okay, we add pi from second quadrant angles. So let me use different highlighter. So we add pi from here to get this angle right here. So if you add pi, which is 3 pi over 3, which is 5 pi over 2, 5 pi over 3. So this angle right here, let me give more room. This is 5 pi over 3, because I add just pi from here. This one, I add pi from 3 pi over 4, which is 7 pi over 4. And this one, let me do a highlighter. From here, I add pi over pi, I add pi to 5 pi over 6, then I get 11 pi over 6. 11 pi, whoops. 11 pi over 6. Okay. So that's how we get these angles. So then, again, the values we get from, we can match with this one. This is matches with this one. Or we can also match with this one in terms of just the numerical value. But you must remember the sign. Here, y is negative, right? Because vertical distance goes negative. So we have negative half, but horizontal distance is positive, square 3 over 2. Square 2 over 2, negative square 2 over 2. Here, half, negative square 3 over 2. Okay. So I kind of went over the whole concept of sine and cosine in relation to unit circle. So make sure you practice constructing this, right? And again, if you want to memorize, think in terms of vertical and horizontal distance relation to sine and cosine definition. And how do we find tangent value here? We just find the slope by just finding sine over cosine. Okay, so tangent is just sine over cosine.